of upstream on a river flowing with a speed of 3.5 meters per second. So you do not know your jet ski speed. Jet ski to water, we don't know. And we also do not know the angle. Is that right? Now, if your velocity relative to the ground, so relative to the ground is given. Your jet ski to ground is 10.5 meters per second, and the angle is 20 degrees. Okay, and the water to ground is 3.5. That is what is given to you, right? All these are given. Is that clear to you? So I am going to draw this. So the water is flowing this direction with 3.5 meters per second. But we do not know V jet ski to the water. Okay? So we can write, as I explained to you, V JW is equal to, how do you write it? Vj plus JG. Ground plus ground to water. Is that right? If you want to find this, we say VJW is JG in GW. Is that clear? So because we are calculating this. Is that clear? We know this, the direction. Okay? Is that clear to you? So VGJ is 10.5 if you look at this way. So to this direction we have cosine 25. This direction we have sine 25. Is that okay? We are doing the same thing, guys. Okay? So we can now write down, since we are adding the component to this direction, which is your x, and then you have y. So x direction is VJG cosine 25, right? Is that clear to you? But now you need to be careful here. Do we know this? We are only given VWG, right? Is that clear to you guys? So if you look at this direction, VWG is equal to 3.5 meter per second. So if you think the positive direction, this is going to be negative, right? Do you understand? If I consider this as the positive direction, this is going to be negative 3.5. But we are not using WG, you are using GW. So if you are changing this, you are supposed to change the sign. So we can say VGW is 3.5 meters per second.
What makes it different? Like WG and GW?
Because your direction is different. GW is going to this direction. Now, see, AB is this direction, therefore BA is this direction. That's what we learned at the very beginning, a few days ago. So we are saying our GW is toward to the other direction. Yes?
But is it GW as ground to water?
Ground to water.
Is there
But
direction for ground?
no, that's the theoretically we can. Water to ground is negative 3.5 because it goes the opposite direction. So ground to water is positive 3.5. Is that okay? That's theoretical. Of course, ground doesn't move comparing to the water. But we are saying it's the opposite direction, 3.5 meters per second.
Does this mean that if we did velocity from to the jet ski would be negative 10.
Yes. Okay. So, but here we are using JG. Is that clear to you guys? This we know. Are you clear here? We are using JG, but that's one we already know. That's how the information is given. Jet ski speed relative to the ground, which is 10.5. But since it has a direction, we take the x direction. JG cos 25. Is that clear? That is the x. Y is towards to the upstream. We have V JG sine 25. Now you have positive, right? Can you see that? Because it's to the direction of this side. Yes? Do you understand why this is positive? Because it's the sign changing and it's the direction is this direction, right?
Was it just plus 3?
Yeah, so you are saying here, to the y direction I have 0.3.
Oh, okay.
Okay, once again, we are looking for VJW. Is it right? That's what we are looking for. So when we arrange this, we are saying this is JG plus GW, right? Because we want to get these two at the end, right? But we are only given WG is negative 3.5 meter per second, right? If you consider this direction as positive, we know the value of WG as negative 3.5. Is that clear to you guys? Up to here? Therefore, if you are changing, your sign need to be changed. So VGW become 3.5. WG is negative 3.5. GW is positive 3.5. Is this clear? Super. Yoshua, did you get that? Why? Jimmy. How about Josh? Are you fine? Okay. Now we are saying, okay, so let's get all the x component and y component. So our x component, you only have VJG cos 25, right? Is that clear to you? Y component, we have JG as well as GW. So you are adding together because they are in the same direction. So what is the value here? 10.5 cosine 25 x.
It's 9.5.
So 9.5. Okay. Y direction is 10.5 sine 25 plus 3.5.
7.9.
7.9. So if you look at your VJW, this is how it is. You have 9.5 x component, 7.9 y component. Okay. Do you know that we organize this equation? JG plus GW. That is clear to you, right? So, but we are given WG. Is that clear? So, WG means to this direction is negative 3.5, right? Because it's flowing down. So, but we want GW. So, we are changing the letter. While we are changing the letter, your direction change, right? Is that clear? WG this direction, GW means this direction. See, W to G, this way. G to W is opposite direction. So that's the reason we change the sign to this direction. You are getting 3.5. Is that clear to you? So therefore, to y direction, they are all towards the positive side, right? That's why you are adding. This is also this direction. This is also the same direction. Is that clear? Because remember, guys, water to ground was flowing to this direction, right? So it is therefore negative 3.5, right? Because it's flowing to the opposite direction. Therefore, when we change this needs to be changed. Sign. Exactly? Because we consider this as the positive. That's why this is negative, right? So we are now adding. So your VJW is your Y component is 7.9. This component is 9.5. Do you get that? Or not? Krishna. Got it? So you can find, how do you find that? Yes. Yes, Angel.
So,
So you need to ask the question if you
yeah,
can.
yes.
Yes.
Okay, so now JG is, you broke it into X and Y components, right? Components, but what about GW?
We can't because it goes downwards, right?
So you made it into WG, right?
Yes.
Which
No,
is-
WG is given, but we made it to G.
Right, GW into 3.5, but that's considered only Y component.
Because it only goes to the Y direction, there's no X component. Because the water flows this way, right? So this component is 0. Because this is 90 degree, cos 90 is 0.
So technically what you're doing is X plus Y plus X plus Y.
Yes.
But then X is 0 here, so you just go X plus Y plus Y.
Is that clear? What about the 11th graders? Are you okay here? How about here? You guys got it? So, can we find VJW therefore? Hello? How do you find VJW?
We have to
Use the Pythagorean. 7.9 square plus 9.5 square. What do you get there?
12.36.
12.36?
12.3, yeah.
36? So I'll say 12.4, something like that. Okay? Meter per second. What is the angle?
39.7.
So tan theta is equal 7.9 over 9.5. Theta is equal 39. 39.75. Is that clear, guys? Now, what I want you to do at home, if you use this V, this is what? VGW, right? This is our first question was like that. Now, if I say, can I erase this part? If I say you have a jet ski that is given, the water is flowing this way for 3.5 meters per second, but you have this, what was this? 12 point something, right? No. 12.4 meter per second, and in 39 degrees, what is the angle we got? 39.75. Okay, let's say. Okay. In this case, can you calculate VJG? If you are given the jet ski is heading to upstream 39.8 degrees, where the water flows 3.5 towards to the down, goes down. Therefore, what is VJG? You should be able to get this and this angle if you calculate back. Calculate backwards. Now you are writing this how? How do you write? You know this is VWG negative, right? Because it's going down. So we are saying VJG should be equal VJW plus V water ground, right? But you know this. That's what I gave you. So you are going to find this now. Is that clear? Are you able to do that?
So you're telling us to do that now?
Not now. That's what you want to try at home and check whether you are getting the same answers.
Can you just tell us briefly again, like in 10 seconds?
What do I need to do in 10 seconds?
You're like go back. You told us.
No, I'm not saying the backwards. I'm giving it as a problem. Again, saying VJW. There is a jet ski. The speed is 12.4 meters per second relative to the water, and it's pointing upstream 39.8 degrees. And the water flows 3.5 meters per second. Okay? Therefore, find the speed of jet ski relative to the ground. So you should end up 10.5, 25 degrees if you didn't do it right.
You're finding G back.
Yes.
You're finding G.
Velocity of JG. Is that clear?
3.5 is water. What?
So when you are writing JG now, there is no sign changes here because JW, WG. Is that okay? So that you are doing at home to study. So we are going to the next section, chapter 4, finally. Sam, I want you to give this. Yes.
Does that how the AP asks? Like, they give you certain and then you find the other?
No, this is just to confirm whether you fully understand how to apply when the givens are this way. Okay? So then you know whichever method you are given, you can calculate. Okay? Alright, so today then we are moving to chapter 4. Now guys, if you have troubles in this explanation, please come and get help individually. I will make time if you come and ask me, okay, I still don't get this part. Okay? Because we are moving to chapter 4. Now chapter 4 is probably making sense now to you because we did chapter 3 and we know if you are given a velocity how to divide it into two components. And in chapter 2 we learned when we throw something how far it goes. Okay? So we are combining that.
What is the VJG?
VJG is what you are looking for, right? So it's JW, and because JG means JW, WG, right? This should be at the, because now you are given this. Is that clear, possible? You are given JW now. Okay. You are looking for this. Alright. So let's move on to our two-dimensional kinematics. Chapter 4. Alright? Did anybody read chapter 4?
We had online last time.
Yes. So which means you are probably familiar with this question. Okay? But I want you to first understand, up to now, you learned very important 1, 2, 3, 4, 5. When something is in motion, whether it's constant velocity or constant acceleration, how to find velocity or the position, all that, right? Can you recall those equations? If it is at constant velocity, how do you find? X final is equal X initial plus
VT.
not V initial, V average. Okay? And if something is in constant acceleration, final velocity is equal initial velocity average acceleration time, right? And we also can say final x is equal initial x, initial velocity plus half acceleration t square. Remember? We learned these things.
But then, number 1 is derived from 3, right?
No, number 1 means there is no acceleration.
So,
Yeah, so this is becoming 0.
so wouldn't 3 still be I? Be initial for 1.
But this is, the thing here, the thing is, it's not completely derived from here. Of course, in this case, if the acceleration is 0, that means initial velocity as well as average velocity is same, right? Because Velocity is going to change. Is that clear? Number 4 is if we do not know the time, we can find the final velocity, acceleration and delta x. If you want, you can write here, some people like to write x final minus x initial. That's also okay. So these are the main equations we learned, but this is the only one that is applicable when the velocity, there is no acceleration, when the acceleration is set. Is that clear? Now, we are going to use all these equations, but our velocity is not into the direction it's moving. So, let's say, I don't know. Yes, we can start from the chapter 4. Okay, here. But before that, I want to give some notes. I just want to show you. Let's say a bar or something moves this direction. Okay, so you are having x and y here, but this object is moving to this direction at 2.6 meter per second. Okay, so we are now going to find out. Therefore, after 5 seconds, 5 seconds, how much it horizontally moved and how much it vertically moved. So up to now what you did, okay, this is moving 2.6 per second. Therefore, after 5 seconds, what is the distance it has gone? How do you find that? So 2.6 is equal distance over time, right? Because we are not worrying about any direction. Speed, distance over time, right? So your distance is equal to 2.6 times 5. So what is that? How much it traveled? 13 meters. So this distance is 13 meters. Right, Subha? Sure. So along the direction he was moving, he moved 13 meters, or the bar, it moved, the object moved. Okay? But if you are finding how much it moved x direction, and let's say this angle is 25, you know how to find this length and this length now, right? That's what we learned in trigonometry. If this is 13, this is going to be 13. What is your dx here? 13 cosine 20. Right? My s is missing. So your dy here is 13 sine 20. Is that clear? So can we find out what is 13 cosine dx? What is dx here? 11.78. Okay, let me say 8 meters. What about dy? 5.5. 5.5. I hope this is right. Are you all okay here?
5.5.
So if you calculate, it goes 2.6 and it goes this much. So you found the distance, right? So also you can say, if that is the case, how much it moved horizontally, how much it moved vertically. That's just giving the coordinates. Is that clear to you? But instead of doing this way, we also can first, this velocity, we can get the x component and y component for the velocity. Is that okay? So if you find your Vx, it is going to be 20.2.6 cosine 25, right? Hello? This direction, Vy, is equal to 2.6 sine 25, right?
Is that when it's...
Instead of calculating distance, because your velocity is to this direction, I am taking the component. If I am thinking about x direction, I can say 2.6, the velocity costs 25, right? So towards the x direction, what is your velocity? Towards to the x direction, what is the velocity?
2.35.
2.6 times cos 25 is what?
2.35.
2 point?
2.35. Or you want to
2.6 cos 25? Yeah, cos 30.
Because cosine 25 is 0.9.
Okay, 2.35. So what about Vy? 1.09. Okay. Now, let's say your x direction, x velocity is 2.35, right? So if you travel 2.35 seconds, what is the distance? So 2.35 times 5 is what?
11.75.
11.75. Instead of calculating distance and getting these components, you can also, right away you can get the component of V towards the x direction and y direction, you still get the same distance. Is that clear? Nagatu. Let's make our big one. So here you can say dx is equal to 2.35 times 5. Vy is 1.09 times 5. You are still getting the same distance. So what I'm trying to say here, yes, you can calculate the distance towards the direction and find out their x component. Or I'm trying to prove that this, you can get the components first of the velocity and calculate your distance. It doesn't change. Is that clear to you?
Which different?
No. Whatever fits there, you should use it. Okay, so what I'm trying to say now, when you are calculating, because the velocity has a direction and a magnitude, you are always calculating x component and y components first. And then proceed your calculation. Got it? So, let's start the question 1 using this. Okay? But guys, which means we are going to organize this now. Alright? All your formulas, let's try to divide it to 2 formulas now. It's not very difficult, we are just thinking about the direction. So you have x final is equal x initial plus velocity to what direction? If you are thinking about the x direction, you have to know the x velocity. So you are getting only the distance to this direction. But if you are calculating y direction, now it is y final, y initial, velocity to y direction and t. Because you are now thinking about the direction. Is that clear? See? You are saying velocity to x direction times t. Velocity to y direction times t. In this case, your x was 0. That's why you didn't have trouble. Right? xi and yi was 0 here, right? Is that clear? This is your first. Here the acceleration is constant. Got it? Number 2, velocity x final is velocity x initial plus acceleration to x direction and t. Time doesn't have direction, so you can use that. Same way, velocity, final velocity to y direction, initial plus acceleration to y direction times t. Now you are thinking about the direction. The basic equations are same, but you need to consider the direction. That's all. Is that okay up to here? So the distance is x is now equal to x initial plus vx initial t plus half acceleration in x direction in t squared. Don't think that there are too many equations. The same equation, we are now thinking about the direction. That's all. Are you all okay here? Because I'm writing so that you would not get confused when you are applying this. Okay? half a by t square. I am emphasizing now you have y and x when you are thinking about as a vector. Up to here you guys are clear? Are you fine? So please make sure you write the final equation as well so that we can apply for all these calculations we are doing today. V x final squared is V x initial squared plus 2ax delta x. V y final squared V y initial squared 2a by delta y. Is that up to here? There's nothing changed, only we are emphasizing the direction. Okay, they are the same equations. Up to here you all are fine? Okay. Now which means you are now doing the chapter 2 again, but considering the direction. Okay, let's do the first question. Okay. Yes. An eagle perched on a tree limb 19.5 above the water spot. Okay. So I gave this much of space not just to write some numbers and circle. I wanted to draw and understand where your x, where your y, all that. Okay. Can I erase this part? So the eagle is on a tree limb that is 19.5 here. The height is 19.5. So the eagle is here. So since we are making this is 0, 0, let's say this is your x, this is your y. Okay? So your y is equal to what? Is it 19.5 because our 0 is here, right? So if you are thinking from here, you are saying, okay, 19.5 from here to here. And then this eagle see a fish, right? Yeah. The eagle pushes off from the branch and descends towards the water. By adjusting its body in flight, the eagle maintains a constant velocity. So eagle doesn't have acceleration. But in this case, generally, we need to think about the gravity, but think that there's no gravity because he's adjusting his body. Okay? So there's a constant velocity, 3.1 meters at an angle of 20 to the horizontal. So this is, so the initial velocity is equal to 3.1 meters per second. So the question asks, how long does it take for the eagle to reach the water? So when it comes, it's going to come like this, right? So there's no acceleration, so it's going to come like this. So in order to calculate, we are going to now break this VI into two components, right? So the x direction is 3.1 cosine 20. This direction VI. What? Yeah. Position versus time. Yes. So VI is equal to, what happened now? We are measuring this way, right? So is it positive or negative? Negative 3.1 sine 25. Right? The great thing is we know this distance. Right? So y final is equal y initial plus v by t. Right? I used it for. Is that clear to you guys? Are you okay what I'm doing here? So what is y final? What is y final here? 0 here, right? What is y initial? 19 point. What about Vy?
Negative 21. Oh no.
Sine 25, which is?
Isn't it sine 20?
Oh, 20, sorry. So what is that? 3.1 sine 20 is equal to what?
Negative 1.06.
Negative?
1.06.
Negative 1.06. So we can calculate the t. Right? Up to, for this bird to eagle to come up to here, this is the time. So you are saying 1.06 t is equal 19.5. You can find the t now. Is that clear to you guys? Because we make our 0, 0 here. That's the reason. Okay? So once you get that t, you can calculate how much he moved this way, right? Can you? Because you know xf, xi plus vxt. This is set. You don't know the final value here. What is vi? 3.1 cosine 20. T is going to be whatever this value. What is that? What is your t you got here?
18.39.
18.4, let's say. So you get how far it moved from here to here.
Use arrow just Vy. Why is it negative 3.1?
Because your direction is downwards, right? Because V is this way, so VIY, the initial direction is opposite direction because we make this is positive, right? The upwards is positive, but your initial velocity towards downwards, right? I component. That's the reason. If it flow this way, your y component is going to be this direction. That's why we say it's linear. Got it? So can you find your final? So is it possible for you to find the last part? What is the location of the eagle 20 seconds after it takes the flight? Not 20 seconds. Eagle 2 seconds after it takes the flight. So remember, it take 18.4 for this eagle to come up to here. So after 2 seconds, it must be somewhere here, right? So in 2 seconds, how much he has gone? And also you can find the velocity. Can you do both of them? Let's quickly do it. After 2 seconds, what is the location of the eagle? Find the location of the eagle. Is that possible for you guys to find? Are you all okay there? Can you find it? Nagato. After 2 seconds. Because it doesn't have acceleration. That's the great thing in this question. So there's no acceleration. Acceleration is 0. So we are saying after 2 seconds, yf is equal y initial plus vyt, right? So you are looking for y final. What is y initial? What is y initial?
19.5.
Plus Vy is negative 3.1 sine 25 sine 20 times 2. Right? Because it's after 2 seconds. Right, Uni? So what do you get here? What's the value?
5.8.
5.2?
Oh.
It can't be. Oh, this is 5.2.
That's
15.25? 2.6 or let's say 3. So he has gone from here to here is 15.3. Make sure that, okay? 15.3 from here to here because we are measuring from here. So this is your final. So he is somewhere here. How much? 19.5 minus 15.3. That is how much he descended. This 15.3 is from here. Do you understand that? The value you got 15.3 is positive, which means it's from here to here it's 15.3. From here to here 19.5. So after 2 seconds he is here, which is 15.3. So how much x value is x final, x initial, bxt, but this is self. 3.1 cosine 20 times 2 is how much he has gone horizontal.
Isn't this 2?
What is
So
2?
it's after 2 seconds?
Yes.
So horizontal would be 2.
After 2 seconds, what is the distance? How much he has?
5.8.
Also it's x and y individual.
Yes.
5.82.
This is 5.82.
5.83.
So this one is 5.83 from here.
Wait, so this is it, no?
Mm-hmm.
So it's position and position. Right?
Yes. X position and Y position. Okay. So now the position has direction, not just a position. X position and your Y.
So we can't see time in the graphs now in 2 dimensions.
What do you mean?
Like,
You have to draw 2 different graphs. To X direction the graph, Y direction the graph. So you can see the graph. Okay. So that is your first question. Would you be able to do the question 2 as homework? Because I want to start projectile motion tomorrow. Okay, so that please make sure you bring this paper. If you want to do everything, that's great. But that's this one, the next page here.
that's homework.
No. Do this question 2 as homework. So I'm going to ask the answers tomorrow. And projectile motion I'll start tomorrow so we can have more questions to practice. Okay? Now, guys, the textbook gives you many equations. But I think it's difficult to remember the equation. If you know the basic equation, you just consider the direction. Okay? So if you want to memorize all the equations, that's totally fine with me. But don't get confused with many equations. It's just the same basic equation. You are putting the direction into count. Oh. Right. 0, right?